Hi YouTube, I've got this USB flash drive in for data recovery. It's made by ComSol and they're pretty common to make USB accessory products. And it's a 4 gig unit. It's already been opened before it come in. And if you have a look at the USB connector, it's bent out of shape. It also shows a bit of gunk. Maybe it's been worked on previously. Let's take a closer look under microscope. So if we have a look at this, we've got a Silicon Motion, a Taiwanese system on a chip manufacturer, and that's the USB controller. It's a bit hard to read. Try and get some light on it, but it is a SM3255Q AB. And that's a reasonably common one. I do see that one over the years. We've got an external crystal oscillator. We've got a bit of gunk around on it, which is a bit weird, and it's brown. I don't know if that's its old age, it's been stained, or has someone put some heat onto it. If we look up here, we can see some solder actually on the connector, so maybe someone's been working on this previously. Bit of corrosion on the capacitors. Is there a LED? No. If we flip it over, we got a single memory chip. We've also got a 2009 manufacturing date. Let's do some probing and see what's wrong. So when we plug this one in, it just doesn't detect, and it draws about 0.05 amps. So sometimes when the USB connector is bent hard, it'll actually crack and damage the wiring inside, and you can usually see it underneath, either up in here or not, but this one looks intact. Up in here we can inspect the pins, and if you actually have a look at this little crystal oscillator, let's zoom in on that. If you notice something there, it's actually broken on this crystal oscillator. So that one there is disconnected. So is that one by the look of it. Yeah, that thing's completely just sitting there. So obviously that might be part of the problem. These days they seem to integrate these devices, so this will be used to keep timing of all the functions. It's your little clock. So I wonder if we can solder that on, or even find out what it is. I wonder if we can get the frequency of this little crystal oscillator. So I might just lift it up carefully. It'd be nice if it was written on there, but I don't think I see anything. It looks like it's in a little oh, there you go, 12. Man, that's hard to read. If you have a look in that digital, what is that, laser etching, I think it says H12.000, 12 megahertz little crystal oscillator. So if I don't want to solder this one back on, I'll get another one. So before I race off and replace this oscillator, I'm just going to check all the other components on there. So we'll check, for example, the USB connector. Okay, with the multimeter in continuity mode, I'm just going to check the soldering of each pin. So we've got a beep there, and I'll just make sure it's not shorted with the others. We'll go to the data pin. We don't have a connection there. Alright, let's check this other data pin. Okay. And is that the ground pin? I can just check. Okay, so that's the ground pin, that's the positive pin. But this one here, and I'll make sure it's not contaminated. I'll try and rub that off a bit. We don't have a connection on this one. So we should fix this before we fix the oscillator. Oh no, we have a connection. Not very good. I'll just swip that around. I might clean that off a bit. Nice and shiny, so we can get a good contact on there. Did look like there might have been some crap on it. Okay, so we do have all 4 pins okay. We'll also just make sure we don't have any shorts to ground, so we'll just quickly run across these capacitors. We have, yeah, someone's been in here. There's a nice shining bowl there of solder. That doesn't look factory, neither does that. So that must be all burnt from someone's heat. Let's check it's working. Right. Okay. Okay, so I think then the only thing that's wrong with this is the oscillator. Let's have a look at the pins though, make sure they're not damaged. Everything looks okay. Let's zoom in a bit. Just checking each of these pins carefully. They all look soldered, and on the back. Okay, I think someone's done a repair job here. They've got a bent and damaged USB stick. They've resoldered the connector back on correctly, but they didn't notice that the oscillator was damaged, or they might have bumped that. It might have got hit or heat. You can actually see it looks quite shiny, and that looks a bit too shiny for a, what are we talking, 2009 14-year-old USB stick and solder. So I think someone's had a crack and they haven't seen this damage here. So I've got myself a new little 12 megahertz crystal, and we'll solder that in place. Take this one out. Looks like it's been glued down for stability. Yeah, no chance in putting that back together. Wonder if I just solder back to these wires. Someone must have been around here. I might just get in a bit closer and check. Looks burnt. What do you think our new design should be? I reckon we go in like this. So let's take out those little trace wires. A little bit of flux to this solder. I'm just going to take these pins out from the old one. And we're going to pick our design. Let's do the 12 facing that way. So I'm going to hard anchor it to that one. That looks good, but I think we'll just bring this one in. Try and get on the other side of that glue. Alright, we should be able to solder that in. Okay, looks good. What do you reckon, guys? Should we fire it up, see if it works? Connected. but not detecting. Okay, it's actually just detected after that. I was going to measure the voltage. 1.3 with the load. 1.2. Okay, it's actually detecting. Let's change screens. So there it is, guys. Good news. We've got access to the USB again. It was just the crystal, so we've got a 2.79 of data to recover. We'll start to copy that across. So if you're new to the channel, welcome along. I upload regular data recovery videos, and I hope to see you guys in the next one. Check this out. For a bit of extra bonus content, we'll have a look at this oscillator on the oscilloscope. So I'm probing one side, and we'll see if we can just do a quick find. So there it goes. We've got a 1.5 volt trigger level, and it might be a bit hard to see, but just in there we've got the 12 megahertz frequency, practically perfect. So let's just check the other side. Let's see what we have. Oh, it's just hard to get the probe in. Okay, so we've locked into the other side now, and we'll just have another look. See if we can automatically detect that. So we've got a negative 1.4 volts on this side, and we've got the same 12 megahertz signal.